Today we're talking about writing equations in slope-intercept form. So when you recall, slope-intercept form is the y equals mx plus b. We talked about how to solve equations to be y equals mx plus b. We talked about the components of this equation, and we talked about graphing them. So remember, the components were the m is the slope, and the b is our y-intercept. So basically, kind of as simple as it looks, if I just was to write an equation with a slope of a -3 and the y-intercept as a 1/2, all I have to do is really plug in around the y and the x. The m is the -3, and the b is the y-intercept, or the 1/2. So the equation of a line that goes with a slope of a -3 and has a y-intercept of 1/2 is -3x plus 1/2. For the next one, same idea. If I look at my slope, that's the m, y-intercept is the b, and when I plug this one in, I plug right around the x and the y. The m is a 0, the y-intercept is a -2. In this case, we would go a little bit further because 0 times x disappears. This equation would be y equals -2. Now, what kind of a line is that? Hopefully you remember back from a previous lesson that the horizontal line is the y equals a constant. So there are no x's in the horizontal line equation. So next we have, how do I write an equation from a graph? Well, from a graph, I need to identify two important parts. So again, if I'm focusing on y equals mx plus b, I first need to know where's the y-intercept. Where does this start? So looking at this first example, it sits right there. 0, -3 would be the b. So I can start to fill this in. There's the y-intercept. And now if I focus on my slope, if I start from any point and go to another point on the line, for example, if I was to start here, 1, 2, 3, up is the rise, right 2 hits the line again of a +2, I could just say 3/2 x minus 3. And that would be the equation of that first one. For the second one, if I was to focus again on my y-intercept, where the graph crosses, or where the ordered pair is the x is a 0, I can start to plug this in. It's crossing at 2. And if I look at my slope, I can go again to any 2 that I can see. So down 1, 2, 3, and then right 1, 2, 3, 4. So -3/4 x plus 2 would be the equation of that graph. So then what I want to look at is, how do I just with 2 points write an equation? So we could certainly graph these 2 points. We could definitely do that. But if you just think about what we've been learning, what we need to know is y equals mx plus b would be a way to write that equation. I need to know the m, and I need to know the b. So the m, trying to figure out what is the rise over the run. So for on this first one, maybe I would do this. 5 minus -1 for my rise over -3 minus 0, my change in x's, or my run for the denominator. 5 minus a -1 is 6, -3 minus 0 is a -3, and so I get a slope of a -2. Then for my y-intercept, or my b, it's the ordered pair that starts with a 0, so 0, -1, that tells me that my y-intercept is at -1. And once I have those two pieces, we just plug it in. y equals mx plus b. So there would be my equation. So here, try the second one and check back in with me. Pause the video, try it, and then I'll show you the answer in a sec. So I've gotten most of the way here, so I figured I'd come back and just make sure we're all together. So finding the slope, I did -5 minus -5, which is 0, for my rise. So my run is a 0 minus -8, which actually is a -8, and that becomes 0. The y-intercept by definition has a 0 for the x, so that's the b. And again, when I first plug this in, I get 0x minus 5. 0 times x is 0. So my equation is just y equals -5. And again, that would be a horizontal line passing through -5. Next, we're looking at writing the equation with the function notation. So again, remember with function notation, what we're really seeing with this notation is not an operation. This is not f times 0. It's basically the f of x equals 10. And in this case, the x is being replaced by a 0. So we want to look at these two, f of 0 equals 10 and f of 6 equals 34, basically as two ordered pairs. This first one, f of x, the x would be the 0. The output, or the value of the function when x is 0, is the y. So there is 0, 10. When 6 is the x value, the function of the value of the function is 34. So 634 is that one. And again, once you have these two, you can find your slope and your y-intercept to write the equation. So the slope, if I did 34 minus 10 as my rise, and then did 6 minus 0, I would get 24 over 6, which is 4. My b, that's the 0 for the x value, for my y-intercept is really 10. So the equation would be y equals 4x plus 10. So again, the function notation is just another way of writing what our ordered pairs would look like. A linear model is basically a linear function that models a real-life situation. When the quantity y changes at a constant rate with respect to the quantity x, basically that's saying slope, we can use the equation y equals mx plus b to model the relationship. The value of m is the constant rate of change. And the value of b is the initial or starting value. Basically, when x is 0, you'd be getting the value of y as your initial or starting value. So let's look at the situation here. So we're talking about how U.S. power plants are using renewable energy between the years of 2007 and the year 2012. And then we're talking about the amount of million megawatt hours each of those years were to try to figure out a model to predict. So notice that down here at the very end of this, we're using a model to predict. It's not going to be anything definite. Lots of things can change those kind of numbers that will tell us that we think this is what's going to happen, so predicting is not a definite, but we're going to try to create something that gives us a way to predict what could be based on what we've seen so far. So a couple of things we first want to look at here. So we want to look at some points, and what I mean by that is some ordered pairs that are coming out of this. So if I look at the year 2007, we had 105 of the million megawatt hours. By the year 2012, we are now up to 219. Now we're not going to use the years 2007 and 2012. We're going to basically call them, in the year 2007 is going to be our starting point. So as far as our time goes, that'll be our 0 number. That's our initial year that we're looking at. 2012 is now going to be 5 years later. So that is going to be at year 5, we're at 219. Now eventually, what we want to know to answer this question is, what do we predict 2017 to be? That's really what we're trying to answer here. And obviously that would be at year 10. So we still want to look at y equals mx plus b. Okay, so here's my m. We want to know the number of million megawatt hours per year to help us figure this out. So if I was solving this, I would need to know that we went 219 to 105, and that was year 5 back to year 0. So just trying to find an average of how many megawatt hours we used each year. If I calculate a constant rate of change, what would I get here? I would get 114 over 5. Which will give me 22.8 per year. And then my B, that is my initial amount. Well, my initial amount is going to be the 105. So remember, my initial amount would be this right here. That would be my B. So at the year 2007, which is where we're starting, that would be the B value. So my linear model that we're going to use here is going to be y equals 22.8x plus 105, which was our initial value. So this is the model that we're going to use to predict future energy use. So for this question, we wanted to know, what is it going to be 10 years down the road? So again, 2017 is not 2017 being plugged in. It's just the year 10 after we started this. So to solve this, all I have to do is take my model and replace the x with the number 10 and then solve. So it appears when x's are 10, y would be 333. Now that doesn't really answer the question. Remember, what does the y represent? It represents this megawatt hours. So we want to say that we expect 333 megawatt hours in 2017 to give that number some context so that anybody looking at this will know that 333 and what it means. And that's how we would use a model to predict. Now again, lots of things can happen. It may be a lot more than that. It might be a lot less than that. But we're using the model that we came up with first with the linear model of y equals mx plus b to try to make a predict the future. Hopefully this makes some sense, and if you have any kind of questions, please feel free to ask me next time we have class.